Military has reportedly developed new technology that improves the performance of high-energy laser systems. According to this report, a new cooling mechanism has been developed by China to enable high-energy laser.
Chinese military ship shining a laser into an Australian Air Force plane.
This is a military-grade laser, so this is designed to destroy radar equipment. We know that our personnel can be blinded.
China's laser cannons are no longer science fiction. They're real, deployed, and changing the rules of aerial defense. From tracking drones mid-air to disabling sensors with silent beams of energy, these systems are now active in live missions and real global operations. But how do they work? Why are they making headlines now? And what does it mean for the future of high-tech security? In this video, we dive deep into China's advanced laser weapons and their surprising global impact. China's high-energy laser weapons are no longer confined to defense expos or classified labs. They're operating in the real world, in high-stakes missions that are beginning to reshape how modern threats are addressed. From drone interceptions to precision targeting systems, China has taken directed energy weapons from theory to field-ready technology. One of the most high-profile examples is the Silent Hunter, a mobile laser defense platform developed by the China Poly Group and showcased globally since 2017. This system is capable of producing beams of up to 100 kilowatts and has already been exported and fielded by international partners. Silent Hunter can disable small drones at a range of several kilometers by precisely targeting and burning through critical components without using traditional ammunition or creating explosive debris. This isn't speculation. There are confirmed reports that Saudi Arabia deployed a Silent Hunter system to neutralize drone incursions, reportedly downing several targets with surgical precision. The system's performance in real-world conditions has significantly boosted its credibility, especially as drone swarms become more common in aerial reconnaissance and interference missions. But China's deployment doesn't stop at drone defense. According to a July 2025 report by Reuters, a Chinese Navy vessel operating near the Red Sea allegedly used a laser system to illuminate a German surveillance aircraft. The incident led Germany and the European Union to summon Chinese diplomats, expressing concern over what they described as an unsafe use of high-energy technology in international airspace. While Beijing has not officially confirmed the nature of the device used, the reaction from NATO-aligned forces suggests this wasn't a low-powered rangefinder. It was a military-grade system with operational capability, capable of disrupting avionics or sensors. The implications here are profound. Laser weapons, once seen as niche tools for specialized threats, are now being used as part of routine operations. And more importantly, they're doing so without physical contact or sound, making detection and response incredibly difficult. China's advancement in this field is no longer just a display of technological ambition. It's a demonstration of readiness. And as we'll explore next, what makes these systems so effective is not just their power, but their precision, integration, and versatility across multiple platforms. Laser weapons sound like something out of a sci-fi blockbuster, but the science behind them is straightforward, yet incredibly powerful. At the heart of these systems is a concentrated beam of light, amplified through advanced fiber optic or solid-state lasers to generate enough energy to burn through metal, sensors, or internal circuits on aerial vehicles. China's flagship systems, like the Silent Hunter and the more recent SkyShield, combine this high-energy laser with a suite of sophisticated tracking and targeting systems. These platforms integrate radar, electro-optical sensors, and AI-driven targeting algorithms to lock onto drones or small aircraft with extreme accuracy. Once locked, the system maintains a focused beam on a specific part of the target, usually a rotor or sensor, until thermal failure disables the drone. The power output is key here. Silent Hunter can deliver a beam strong enough to burn through a 5mm steel plate from over 800 meters away. In practical terms, that means a hovering drone with plastic housing and exposed circuits can be disabled in seconds without making a sound or alerting nearby radar systems. One of the most groundbreaking aspects of these systems is their cost per shot. Unlike traditional missile defense platforms like the Patriot or HQ-9, which can cost hundreds of thousands of dollars per interception, laser systems consume only electricity. Once deployed, a shot costs a few dollars at most, making it ideal for situations involving multiple small drones or repeated intrusion attempts. Another critical feature is mobility. Both Silent Hunter and SkyShield have been designed to be mounted on vehicles, meaning they can be deployed anywhere, from airfields to sensitive border zones, and repositioned as needed. That flexibility is rare in advanced defense systems, which often require fixed installations. But what truly sets China's laser systems apart is their export readiness. Unlike many Western equivalents, such as Israel's Iron Beam or the U.S. Navy's Helios program, China is not only developing these systems rapidly, it's also offering them to partners worldwide. This positions Beijing as both a technology innovator and a global supplier of next-gen defense platforms. China's lasers aren't just working. They're efficient, portable, scalable, and increasingly attractive to nations seeking non-lethal options for modern threats. And now, the impact is not just technical, it's strategic, as we'll see in the next section. China's laser weapons are more than just engineering marvels. They read a signal of shifting power in the global defense landscape. These systems are being deployed, tested, and sold in ways that redefine how nations respond to aerial surveillance, electronic incursions, and low-cost drone threats. One of the most significant strategic implications is export and proliferation. China has already exported the Silent Hunter system to at least one foreign power, Saudi Arabia, and has reportedly offered similar systems to other clients across Asia and the Middle East. This isn't just about sales. It's about shaping military alliances with cutting-edge technology that Western nations are slower to release. The geopolitical ripple effects are already being felt. The July 2025 laser incident with Germany wasn't just a technical issue. It was a diplomatic signal. The German government didn't simply note a technical anomaly. They called it an unacceptable risk to personnel and summoned China's ambassador. The European Union followed suit, escalating the matter diplomatically. In a world where drones and surveillance aircraft are routinely used for monitoring and early warning, a working laser capable of interfering with flight operations represents a new frontier in signaling and deterrence. Laser weapons also raise complex legal and ethical questions. Unlike missiles or guns, a laser beam leaves little physical evidence but can cause serious harm to sensors, optics, or even human eyesight. This opens the door to gray zone tactics, actions that fall below the threshold of armed conflict but still exert pressure or cause disruption. Unlike traditional systems that are detectable by radar or infrared, laser weapons are incredibly stealthy. They don't generate ballistic arcs or heat signatures that early warning systems are tuned to recognize. This stealth factor adds another layer of complexity to national defense systems and challenges the assumptions that underlie traditional rules of engagement. There's also the doctrinal shift laser weapons introduce. Rather than focusing solely on deterrence or overwhelming force, these systems enable a new form of soft disruption, using directed energy to blind sensors, disable reconnaissance assets, or deter surveillance without physical destruction. This could change how border incidents, airspace violations, and even maritime surveillance are handled globally. In short, China's laser systems aren't just about melting drones. They about shifting the balance in how modern nations defend their skies, assert control, and influence global norms. As the tech matures and becomes more widely adopted, we're entering a new chapter in aerospace and defense, one where light, not firepower, takes the lead. China's laser cannons represent more than a technological milestone. They mark a silent but profound shift in how nations safeguard their skies. From neutralizing drones in real time to signaling power through targeted energy beams, these systems are reshaping global defense strategies with quiet precision. As their deployment increases and their capabilities evolve, it's clear we're entering an era where directed energy, not just force, defines airspace control. And with global powers watching closely, the real question now is, who will lead in the race for energy-based defense? Thanks for watching. Don't forget to like, share, and subscribe for more.